it's report time, and I must admit I'm just a fraction behind in my marking. So Bromley in particular, Friday I wasn't on site and you had an urgent question and I wasn't able to respond. So Bromley, later on today we might try and catch up with each other. So what I want to do today is check that the Lightbook is functioning for people. So last term there was definitely problems. The majority of students are not having problems, I'd like to say, but there are some problems. One that I'm aware of is if you've got Windows 10, then you've got to allow Flash to run. And if that's a problem that it's not even opening, I know how to fix it. The other problem that people had last term was PDF. Yeah, that some of the answers weren't saving. Now, the company was aware of that and they claim they've fixed it. So, what I'd like to do at the start of today's lesson is to open up Lightbook 5.3 and let's look at some questions, make sure that they save for you, and help me to be confident and you to be confident that it's working properly. So, can I have a tick if you've already got it open? Excellent. So I'm just going to put that whiteboard back. So I'm just going to give you 2 minutes to do some more of those questions. Now, if you've already done all of 5.3, just go back and maybe look at, make sure that just do some questions, please, in chapter 5. Oh, have you had a shot at making diamond lattice? Has anyone done that? Heidi, would you tell the class or Emmy what happened and what you observed when you were making it? You need to unmute if you're going to talk to the class. I've got silence. Heidi, are you talking? Emmy, do you want to try and talk or otherwise text chat?
Can you hear
I
me?
can hear you, which is wonderful, Emmy.
Okay, because it still looks muted on my screen.
Oh, okay, so
It's just that my internet is really slow, so it's kind of lags.
yes, and Emmy, sometimes when you try and talk, you drop out, which is a bit alarming, but all's good at the moment. So could you just share with the class what happened when you made the diamond lattice?
It was pretty strong, but it was hard to do because the toothpicks were too long for the size of the tubes, so it was kind of unstable.
Yes. So when you started, did it start strong?
Um, Not really.
Okay, so at what point did it start to sort of hold together?
I think it was when you got kind of two rows of the base together and joined them at the top.
Yeah.
If that makes sense.
So sort of adding, like if you took one tube as a carbon and like carbon has 4 single bonds. So when two tubes were connected in a row plus a second row, is that what you're saying? So they were connected in more than one direction.
Yeah.
All right, Heidi, thank you very much, Emmy. Heidi, did you have a similar experience? I'm not sure what's happening. I think we've got poor connectivity today. So I'm going to push on because you're obviously hearing me. But Heidi, if I know that sometimes the mute won't unmute, so if you can't unmute, I can do it for you. But please chat to me if you're having problems your end, anybody. So in the Lightbook Starter, in question 4, which you might already have open. So if you've got the Lightbook Starter open, can you open up number 4? Or if I'm very lucky because I've got more than one screen, but if it's too crowded, then just watch the WebEx. So sort the metals from least reactive to most reactive. I want to answer the phone so maybe do this one yourselves. Okay, smiley face if you were thinking, because I'll need some response here. If you were thinking but you weren't sure that the alkali metals are group 1, so lithium, sodium are alkali metals. Smiley face if you say, oh yes, I vaguely remember that. Oh good, that's good. So you're very gradually building up all sorts of knowledge, and it's almost like a code. So when I say alkali metals, students who are up to date with their work, I'm hoping you will say, oh, they are metals, they are shiny, they conduct electricity. So light globe, is this true? Do you know those are properties of metals? No light globes, not yet anyway. I think we've got very slow connectivity. Um, and the other thing about group 1 is their chemical reactivity depends on the electrons in their outer shell. Can you all text chat? How many electrons in the outer shell of group 1 elements? Okay. I'm not getting many responses. Group 1, I hope you're beginning to understand. Yeah, dropping out, which is really frustrating, you guys. Thank you for telling me. Yes, Emmy? Emmy, you're still muted if you're talking. Look, we seem to be having very slow connectivity. Can you give me a tick if you're happy if I just talk? Only one tick? Oh, yeah, a couple of ticks. Oh, good. So I'm going to talk and I want you to respond with your emoticons and with your text chat because a lot of the things I'm saying, I hope are confirmation of what you know already. So when you do those answers into the light book, you've got a whole heap of knowledge you've got to pull together. So when I see alkali metals, it means that I need to know that they're group 1. I also need to know that group 1 has 1 electron in the outer shell. So if I just check with lithium, lithium has an atomic number of 3. It has 3 protons. If it has 3 protons in the nucleus, then it's going to have 3 electrons in the shells. And I hope you're beginning to know the first shell is full with 2 and chemically stable. The chemical reactivity is due to the electrons in the valence shell, and lithium only has 1 electron in the valence shell. In fact, all of the group 1 elements only have 1 electron in the outer shell. So I want a smiley face. Do you understand that the chemical reactivity is similar because of the 1 electron in the outer shell? So I'll wait and see if you respond. I want more than one response. So if you don't understand, can you put up a cross So Heidi's saying yes, she understands it's the electron that is involved in the chemical reaction, and it's the outer shell electron that tends to move, and it's moving electrons that are involved in chemical reactions. Give me a tick if you heard me, even if you don't understand what I'm talking about. That's good. Thank you, Kalisha. All right. So we are very interested. We've organised the elements into the periodic table because they've got similar characteristics, and then we're seeing, oh, the way the electrons are in energy levels, that's relating to the chemical reactivity. And what we find is that the group 1 metals all tend to lose that one electron, and they end up with a positive ion, a single positive ion. So even though I know pretty well nothing about Frankensteinium, in fact, I'm not even sure what it is, like I'm not sure that I've pronounced that correctly. If I look at FR, I know because it's in group 1, it's going to have one valence electron, and that when it is involved in a chemical reaction, it's probably going to form a single plus ion. Can I have a tick? Do you understand that you can just look at the group and predict what ion is going to form? So I'm hoping for ticks. I'm hoping you're looking at RB, which is rubidium, and saying it's in group 1, so it's got one valence electron. Therefore, if it's involved in a chemical reaction, it's likely to lose that one negative electron, leaving a positive overall. Do other people have the same trouble as Heidi, that my audio is unclear? Yeah, a little bit. I'm going to keep going and taping. Please keep talking to me. If it's too bad, please disappear, and I'll offer another one of my other lessons that you might want to join. So let's see if things improve. It's very frustrating. So in a similar way, when we look at the chemical reactivity down a group, what we find is as you go down the group, the reaction is stronger and faster. So the reactivity is stronger and faster down the metal groups. Now, if I go to the whiteboard and I quickly redraw lithium, so lithium had 3 positives and it had 2 shells occupied, so it's in period 2, and 1 electron in the outer shell. Sodium is similar in that it's got 1 valence electron. So sodium is 11 protons in the nucleus. That means it's got 11 electrons. The first shell is full and stable with 2. The second shell is full and stable with 8. We're now up to 10 electrons in shells. So that leaves only 1 electron left. So here's my 1 electron. Now the difference between lithium and sodium is the number of shells. So 3 shells occupied for sodium, and I'm just using the symbol for sodium, and only 2 shells occupied for lithium. Now what that means is there's a force holding the positive and the negative together, and the further away, the weaker the force. Can I have a smiley face if you heard me? That if you get further away, the holding force, the attraction force is weaker. I'll try again. Yeah, attraction force is weaker the further away. Oh, lovely. I love those responses. I'll try that again. I'm typing this time. Because it's further away. Okay, so I've just typed that up. The attraction force between the negative electron and the positive nucleus gets weaker the further away. So let's go back to the periodic table. The period, hydrogen has one shell occupied. Lithium has two shells occupied. Sodium has three. Can I have a tick? Do you understand that as we go along the rows, more and more shells are filled up or are occupied? It's the holding on to the electrons is less. It's going to react quicker. A tick if you follow that reactivity increases down. All right. Not getting any responses. The reactivity for the metals increases as you go down. I'm going to leave it there. I hope with your reading that you notice that information, that the reactivity for metals, because metals tend to have the outer valence shell less than half full. Now, I'm going to let you do some highlighting. I want you, or circling's probably better. I want you on the periodic table to get out the green. I want you to circle any metals you know. And all right, so I'm giving you a minute. Any metals you know, please circle them. And this means you need to know some symbols. So if you say, oh, I know copper is a metal, but I don't know the symbol, text chat and say, what is the symbol for copper? All right, so if you know that lead is a symbol, but you don't know the symbol for lead, we can tell each other the symbols. So we've got iron. Fe is a symbol for iron. And PD. It is a metal, but I don't know what it is. I don't know. Can anyone type the name for PD? Palladium. I think it's palladium. All right. I'm going to also highlight a couple yes, lithium is a metal. Copper is a metal. Right over on the right here, aluminium is a metal. And you may not know the symbol for tin. SN is the symbol for tin. Some people know that magnesium is a metal, so magnesium over there. Everyone, I believe, knows that gold, AU is gold and AG is silver. I think most people know that they are metals. Titanium, yes, titanium's a very strong metal. Zinc, I think someone just highlighted zinc. ZN is zinc. You may not have found it, but silver, AG for silver, AU for gold. And mercury is Hg, cadmium. In fact, I'll do a big circle. Many of the elements, including transition elements, are metals. Yes, chrome's a metal. Hydrogen we include because it's got metallic properties, but it's got some non-metal properties as well. Most of the elements have metallic properties. Now that's partly because the transition elements, which have some inner shells that aren't full yet, they often have one electron or two electrons in the outer shell. In fact, if we go up to 3 electrons in the group outer shell, so group 13 have 3 electrons in the outer shell. If 8 is the stable number that we're after most of the time, 3 is less than halfway. If we're less than halfway, it tends to lose electrons and form positive ions and tends to be metallic. So they're all metals. Can you please change to a blue? Non-metals, people don't seem to know as much about non-metals. Non-metals are often part of organic compounds. So I'm going to name some non-metals. Can you circle or highlight them in blue? Nitrogen is a non-metal. Nitrogen is often combined with other things and used in fertilizers. So ammonia has nitrogen in it. So can you try and find N for nitrogen? Phosphorus is another non-metal. So if you find the blue highlight, yes, hydrogen has non-metallic qualities. Hydrogen has both. So there are a couple of elements that sort of are in a category on their own, and hydrogen is one of them. Actually, that blue, can you swap to light blue? So we've got nitrogen and oxygen highlighted. Phosphorus is a non-metal. Phosphorus is used in match heads and it burns well. So phosphorus is a non-metal. Sulfur is a yellow powder that if you've lucky enough to have been where volcanoes have been erupting, there's often sulfur around volcanoes. It's a non-metal. So P and S are non-metals. Chlorine gas, fluorine gas are non-metals. So these are symbols that I hope that you're beginning to know. So F for fluorine, Cl for chlorine. See if you can find them and highlight them. Bromine. People may have noticed that if you've got antiseptics, if you've got that iodides and bromides are antiseptic, so they are also non-metals. So bromine, Br, well done, and iodine is the I, and chlorine. Chlorine actually kills bacteria when it's combined with other things. Now, the elements are so reactive that they don't usually exist in a pure form. Even the metals, very rarely in nature do metals appear in pure form. They're often in an oxide or a more complex form. So the periodic table is very artificial. About the only things that appear in pure form in nature are the unreactive ones. So we've started to highlight the non-metals, which are very reactive, and they in nature they are combined with other things. So I'm just going to do a little blue circle around the non-metals. The non-metals include carbon, phosphorus, selenium, all right, down here, iodine, nitrogen, oxygen. They are the non-metals. So there's not so many of them, but they combine with lots of things. Now, in between, we've got the brown. The brown actually have a little bit of a non-metal and a little bit of a metal. They don't fit exactly in either category. So the transition elements have it's not really showing on this diagram, but the transition elements also have non-metallic properties in them. The transition elements are really colourful compounds. So when we had that prac, no, they weren't all transition elements, but in general, you'll find out that a lot of the non-metals form very colourful compounds. Um, so there's just a lot of interesting things just to build up your knowledge. And when you go to answer the questions in the Lightbook Starter, unless you've read the chapter, you're just not going to have any idea. So have people found that to do the Lightbook Starter questions, you really have to have read the chapter? Give me a tick if you found that out. It's not possible just to go to the end and say, I'll see how many I can answer without reading the chapter first. You'll just be frustrated. All right, the other thing, so if you've got your Lightbook open, I want to go on to the next bit because there's some questions that are a bit tricky. Let's go to question 7. Let's see what that one's like, which is magnesium reacts with water to form magnesium. And I'm just going to share my desktop. So please go in yourselves as well. Now, because I'm recording, sometimes I have a bit of trouble getting to the document, but we're told magnesium reacts slowly with water. So you've got to gradually build up your knowledge. You need to be able to know that magnesium is Mg and water is H2O. Now, they give you the equation, but you've got to actually be able to match it up. So the word is magnesium reacts slowly with water. You see the magnesium symbol, you see the water symbol. And it forms magnesium hydroxide. Now, you haven't really learnt that. That is new to you. So you've just got to calmly say, oh, they must be talking about this formula because it's got the magnesium in it and it's got something else that I've never heard of before. That must be the hydroxide ion. So there's a little bit of trust here that you're going to gradually build up your knowledge. And hydrogen gas, hydrogen as an element is just the single letter H as a single atom. But hydrogen is not stable as an element. It bonds with itself and forms two atoms bonded together. So that's what the little 2 means. So you've got to use that information in the equation to answer the following questions between calcium and water. So they're really saying what they want you to realise is calcium and magnesium are in the same group. So I'm just going to tell you that they're both in group 2. They both form 2+ ions. They actually tell you it's alkaline earth metal, which is, they tell you it's the same group as magnesium. So they're saying follow the pattern. And so you can just type in calcium is going to combine, it's going to have similar chemical properties. They want the word equation, sorry, so they actually want you to write the whole word. And the box expands. It's going to form calcium hydroxide and hydrogen gas. Oops, can't spell. Hydroxide. So it'd be interesting to see if I do a misspelling whether it'll reject it. Okay, now I believe that that's correct. And it says it's incorrect. Calcium hydroxide and hydrogen. So I'll look at the help. I don't think there's anything wrong with it. So Next hint. So when it says the products are written on the right-hand side, calcium hydroxide and hydrogen are products, have I misread the question? I don't know what's wrong with my answer. I believe it's correct. So let's see what the answer is. So calcium, I think, can anyone guess? I'm guessing that it's wrong because, yes, what do you think?
In the answer, like it's got not like it's all correct, but it's the capitals on the calcium.
Yes, I agree. So please, when you're doing this, it's always with online things. If you're not really confident and it picks up a spelling error or a typing error, it's very frustrating because it can damage your confidence. Or otherwise, you might say, oh, silly program, my typing error. But please be very, very careful with your typing. So now that I've fixed it, if I click save, that's going to tell me. So I'll just show you I don't know that it tracks me. That's the problem. But I don't only use the tracker. So when I look at your answers, I look at what you've done. So in the weekly work, partly you're practicing using the Lightbooks data and making sure that you're familiar with some of the little tricks of using the program. All right, so that was quite a good one to show where I made a mistake. Now I want one. It might have been in in 5.2. There are some programs, some of them where you've got to drag and drop. Can I ask, have any of you had trouble answering the questions because you don't know how to use, how to type in the answer? Has anyone had that problem? All right, sometimes. So I guess what I'm asking is shoot me an email if you're having hassles. And actually, I might even make a tiny little video when I find a question that I think is a little bit tricky to use the software, not necessarily to answer the question, but to use they call it an asset, and we have to learn how to use it. So let's see how much I've covered. This idea of reactivity changing down the group and the metals, so an alkali metal group 1, transition metal, you've got to perhaps look at the periodic table to find them. Halogen is group 17. It has 7 electrons in the valence shell. It's going to want to gain an electron to get that stable 8. So if it can manage to get an electron from some other element, it will go from having 7 of its own valence electrons. So I've got 7. I'm changing my colour scheme. And if it can grab an electron from somewhere else, it now has a stable 8. So it's got 1 extra. So I happen to know that chlorine is a halogen. If it gains an electron, it's going to have a negative charge. So all the non-metals tend to gain electrons. They all tend to form negative ions. So they are the sort of patterns that I hope that you begin to notice, because in our next topic, you need to know those things to write balanced equations. So we're just beginning to do equations. So when we do the equation for calcium and water, you you need to know the symbol for calcium. Give me a tick. Have you begun to build up your knowledge of the symbols of the first 20 elements? Tick if you're starting. That's really good. So you need to put effort into that, otherwise you get stuck. So I know the symbol for calcium. Water is made of hydrogen, 2 hydrogen atoms bonded with an oxygen atom. So I happen to know that there are 6 electrons in the valence shell, the outer shell of oxygen. That means oxygen wants to get another 2. Hydrogen only has 1 electron. Now hydrogen, the first shell is stable with 2 electrons. So if hydrogen can share an electron with oxygen, it will have it stable 2. And if oxygen can share with 2 hydrogens, it will have it stable 8. Can I have a tick? Do you follow how these electrons can move and they don't stay in one spot? So, the hydrogen electron is whizzing around the hydrogen some of the time and around the oxygen some of the time. It's shared. That's called a covalent bond. So I've done that pretty quickly. It's something you guys have to practice during the week. But that is why in water is 1 oxygen atom and 2 hydrogen atoms, and we abbreviate it. That little 2 means there are 2 hydrogen atoms, and that O, we don't write a 1 there. If you've got just the symbol, it means you've got 1 of them. So there we are, we've got water, and we know that it forms calcium hydroxide. Now, at this stage, you don't really have the knowledge. The hydroxide ion is a complicated ion that has a negative charge overall. So oxygen and hydrogen have a covalent bond and it's pulled in an electron from somewhere else. That is called the hydroxide ion. So that bit of knowledge is just sort of dumped on you. And because you're beginning to know that calcium forms a 2+ ion, it's in group 2, it's going to lose its 2 valence electrons, it's going to form a calcium 2+ ion. Now, when things form a network, they form a network between charged particles that end up with a 0 charge overall. So, if you accept that the hydroxide ion has 1 negative, we're going to need 2 of them to get 2 negatives to balance the 2 positives. So what we do in the formula, we've got 1 calcium ion with 2 positives. We need 2 hydroxide ions, each with a negative. That's all hidden in the formula. And then hydrogen gas. So at this very early stage, you'll probably copy the pattern. You'll say that because calcium is like magnesium, it's in the same group, its equation is going to have the same pattern. So at this stage, we're saying copy the pattern. What I've just done with you is I've said there is a reason for the pattern, and you need to be aware that you've got to get the basic learning, otherwise you won't be able to understand the pattern. Can I have a tick? Do you follow that I've sort of talked about things that you've got to begin to understand and you're only at the early stages? Because I think sometimes students get a bit stressed out at this stage because there's all this stuff that you don't really know yet, and you've got to give yourself time and you've got to put energy into learning. All right, so I've really written the calcium hydroxide, the calcium plus water reaction. I've written it from understanding, but you're going to write it from copying the pattern. And you can copy the pattern because you know it's in the same group. All right, now let's see what else. We've talked about the reactivity of metals increasing down the group. Okay, let's see if people can talk. What do you notice about these reactions that I've got up on the screen? Yes, I was speaking. I'll try again. What do you notice about the two reactions on the screen? Yes, Emmy?
That there is, in the result, there's not a second chlorine atom.
Okay, so you're saying here the lithium chloride, it's just one lithium and one chloride. Thank you. Do people notice other things? Oh, Emmy, try and tell me again.
It started with 2 lithium and 2 chlorine, I don't know, but there was only 1 chlorine in the result,
All right.
but 2 lithiums.
Ah, so Emmy, that big 2 out the front means 2 lithium chlorides. So it means lithium chloride twice. So can you see now that it does add up to 2 lithium atoms and 2 chloride atoms? So that's really good noticing, Emmy, and it, we keep learning. We've got to understand what all the symbols mean. Anything else that people notice with those equations about what's similar? Now this really, it's a pity that I couldn't have the periodic table up. But lithium and sodium are both alkali metals. They're both in group 1. So we're expecting them to have similar chemical properties. The other thing that I hope you're noticing, so smile a face if you notice, they both are reacting with chlorine. So both reactions have the same, one of the reactants is the same. Give me a tick if you say, all right, from that equation, Cl2 is chlorine gas. I can see chlorine gas. Please give me a tick if you follow that symbol. And across if you don't understand what I'm talking about. Okay, we've got sound problems. I'll keep going, not for much longer. So when it says suggest a similar reaction, what we need is I'm going to type this, to be similar, we need an alkali metal and chlorine gas. So if I go back to the periodic table, we want another, actually this will do. Lithium and sodium are alkali metals, so is potassium. So let's use potassium. So potassium is K. And we're going to add it to chlorine gas. So Cl2. So I'm matching the Cl2. And if I'm going to follow the pattern, I probably need 2 potassiums. And then the product is going to be potassium chloride. And if I'm going to follow the pattern, I'm going to need 2 of them. Can I have a tick? Can you see how I've matched the pattern? And see, I'm not getting ticks or crosses. I've matched the pattern because they're in the same group. Because lithium, sodium, and potassium are in the same group. Okay. And we can do the same again, but time's got away from us. So just very quickly, again, we've got sodium in an alkali metal and lithium an alkali metal. They're in group 1. This time they're both reacting with water. They are both forming sodium hydroxide and hydrogen gas. So if I follow the pattern and I take potassium, which is a group 1 metal, well, the pattern is I needed 2 of them, and it reacted with 2 water molecules. And the reaction produced potassium hydroxide, and I had to have 2 of them, and hydrogen gas. So I've followed the pattern. All right, and actually this last slide was trying to explain that it's not just the electrons that react, that cause reactivity, it's the distance of the electrons away from the nucleus, which is the number of shells. So the number of shells occupied, which is the period, so period 1 for hydrogen, 2 for lithium, 3 for sodium. As we have extra shells occupied, the electron is further and further from the positive charge in the middle, in the nucleus, and it can lose that electron more easily. That means it's more reactive. And so I didn't get to group 14 because we had a bit of a slow start. So I'll have to recap that next week. Okay, people, thank you for your patience. I'll send an email and I'll send this as a recording, but I might send another lesson recording where the sound is working better.